Okay, we're doing logic puzzles again today. So I'm going to introduce you guys to a few new ones. This first one's called the Ken. Don't know why. But basically you're going to fill in the numbers in each row or column. Okay, so these instructions are a little bit, you need a little help, so that's why we're here. Fill in the numbers in each row or column from 1 to grid size. So if it's a 4x4 grid, 1 to 4. The 6x6 grid down here, you're gonna have to do 1 to 6. So each row needs 1 to 4, where each column needs 1 to 4, kind of like a Sudoku. You don't want to repeat a number in any row or column. The numbers in each heavily outlined set of squares, called cages, so you can see here that there's like darker outlines around some of them, okay? Must combine in any order to produce the target number in the top corner using the mathematical operation indicated. So like this cage, for example, here, it's got 2 boxes and they need to add to 3, okay? We know we're gonna need 1s and 4s, so this is gonna be, 1, 2, 3, and 4, 1 through 4. So it's probably gonna be some kind of combination of 1 and 2, okay? But we just don't know which one's where yet. Cages with just 1 square should be filled in with the target number in the top corner. So something like this can just become a 1 right away. So see how we've got that bold line around just that 1 box, so that's a 1. And then a number can be repeated within a cage as long as it's not in the same row or column. So this example that we're gonna do, there's not actually any cages that go into one more row or column, but something like this, like if you used a 1 here and a 1 here, that would be okay even though they're in the same cage because they're in a different column and a different row. So now we need to work through the rest of it. So we know that we're gonna have a 2, 3, and 4 across the rest. So if I need 2 numbers that add to 3, and I can't put a 1 here, right, because there's already 1 in that row, this one has to be a 2, and then this one would be a 1. And then this cage has to divide to 2. So either I could use a 2 and a 1, but that can't work because both those numbers are gone in this row. So if I put a 4 there and a 2 there, 4 divided by 2 is 2. And then that makes this guy have to be a 3. So then from there, we can kind of go through, okay, well, what else do we know? I know that these 2 need to subtract to a 1. So I could use 2 and 1 again. I could use 3 and 2. I could use 4 and 3. There's not a whole lot of definitive anything there. If I need to get to 12, if I put, so this one either has to be a 3 or a 4, right? So in this one and this one, my only options left are 3 and 4. So if I put a 3 there, I would have 9, and then nothing else would evenly multiply. So this one has to be a 4. And then 3 times 4 is 12 already, so that makes that one have to be a 1. And then in this row, we know that that one's a 3. So now that we've got a little bit more information around here, we can say, okay, if these need to subtract to 1, it can't be a 1, so it can't be 2 minus 1. So it could be 2 and 3 or 3 and 4. So this one couldn't be a 2 or a 4. So really the only, because we said 2 and 3 or 3 and 4, right? This row can't have a 2 or a 4, so this one would have to be a 3. And again, we don't, in this row, because there's already a 2, it can't be that, so it would have to be a 4. Okay, the other ways that we could have done this is, as soon as we knew that much, we could have filled in the 2 down here. We still probably would have had to figure that out, but now that we know this one has to be a 1, this one has to be a 3, those all add to 6, we must have done something right. So then we've got 2, 1, 3. This one has to be a 4 in this row. And then this one has to be a 2. Those 3 multiply to 24. So we've solved it correctly. Okay, so there's a couple more to try. Obviously, the bigger one is a little bit harder. Your numbers get a little bit bigger, but always start with like this guy. That's a 2 right away. Okay, so this guy's a 5 right away, right? Start with the easy ones. The next one is a cryptogram. So we want to develop a key for each letter, and by develop I mean like fill it in. So it just is going to go A is 1, B is 2, C is 3, D is 4, E is 5, and so on. Right? So and then anytime you'd see a 1, you'd fill in an A. The 2s would be B's. Right? There's another A. So you're just using that code to figure out what the phrase is. So there's a couple of those. The next one is Hanjie. So the numbers tell you how many squares in that row from left to right, or column from top to bottom must be shaded in. So a comma or a space means that you have to leave at least one blank square between the blocks, and we can use logic for every single step of this puzzle. So when we start one of these, I like to look for the biggest numbers first. So you notice how this one, there's this little arrow. It means to start in this row. None of the other ones have it, but just, you know, because this is our demo, this is what we're gonna do. So if it goes 1, 2, 3, 1, that means one block has to be filled in, and then we have to leave at least one. It's not always just one, but at least one. Then 2, then at least 1, then 3, then at least 1, then 1. Okay, so if I actually counted that out, if I filled this one in, left 1, filled 2 in, left 1, filled 3 in, left 1, filled 1 in, that would take up this entire row. So that's the only way that this, or this column, works. So I like to color them in. And then I also like, there's an app that I actually play with this game that I actually think those puzzles are easier. So if you want to know the app, let me know. So now I put X's saying, okay, it can't be there. Okay, so now I need to look at other columns or other rows that I know things about. If it's going to be a 6 and a 1 and a 1, again, I look at the highest numbers first. If we had 1, 2, 3, 4, 5, 6, blank, 1, blank, 1. Okay, this one would also be a really good one to start with. X, 1, X, 1. Okay, now if I start looking at some of the rows, this one has to be 4 in a row. So this one's definitely going to be part of it. And then we just have to figure out, okay, is this the square that's filled? Or is this? So I'm going to say, okay, well, it can't be any of those guys because that would be bigger than 4. Then 1 and 1, I mean, it could be any of these ones. It could be that one. There's nothing really decisive yet there. Same with 2, 4, and 2. So 2x4, x2. Okay, so this one, the only way that it'll fit is to do 2, and then an X, and then the 4, and then an X, and then the 2. Okay, so we've dealt with, and I kind of like to cross them all off as I've dealt with them. So this one we don't know enough about yet. 4 and 4. So what this X tells me is that these 4 have to be shaded because the only way the 4 and like 2 4s could fit is if one of them was on this side and then the other one's going to be over here. So these 2 are definitely going to be shaded, and then it's that, okay, which one is it going to be? We don't know yet. Then we have another 2, 4, and 2. So 2, blank, 4, blank, 2. So these ones we can do right away. Oops, that one should have been an X. Okay, so now if we look at this column, and so we've dealt with all of those, we've only dealt with that one. If we look at this column, there's 4 in a row, so this one has to be filled. So this one has to be an X because that 4 is now full. So now we could look at this one and say, okay, this up and down one, we've got 1 and then a blank, and then 1 and then a blank. So we've dealt with these 2 ones. And then there's 5 in a row. So we have that starting one. 1, 2, 3, 4, 5. And this one has to be empty. So what it tells me is this, if we look at this one, I've got 1 on the left of the blank and then 2 on the right of the blank. And those ones are all X's. This next row, I've already got my 2, so I can just X out the rest of them because I know nothing else is going to go in those. 6 is a little tricky. There's nothing really known on either side yet. 8, with a big number like 8, we can say, okay, well, if I start counting from the edge, if it went all the way to this edge, we'd have 1, 2, 3, 4, 5, 6. And then these 2 would have to be filled in. So that's as far as this like block of 8 could possibly go over there. If we went from the other side, we could go, okay, from here, 1, 2, 3, 4, 5, 6, 7, 8. Right, so that's the minimum space that 8 block can take up in the middle. We don't know the edges yet. We don't know if it's like all the way up on one side or all the way up on the other side, but we know enough to just put those 6 in the middle. And these 2s, so this is a block of 2, so clearly that one. And then on either side, we've got 3, so definitely the middle one on either side has to be part of the 2, and then we just don't know left or right between those. Okay. Then, yeah, the bottom, there's not much to know about any of those other rows. So now we go back up and down. 4, it's not decisive. It could be there and make the 2, but it could be there and make a 1. We don't know yet. 5, same deal. It could be up here and make the 5. It could be down there and make the 1. We don't know yet. This one's going to be a 2, a 1, and a 1. So here's a 1, right? That one's got to be, because this has to be the 2, right? One of these 2 has to be filled in for the 2. We just don't know which one yet. Here's a 1. This one has to be a 1, right? Because we have a 1, and then there's the 2. Okay, so I would say that that's probably the 1 on the left, but I guess there could be a 1 there. What we do know is that these guys are gone. We can't put them beside there. Then we've got a 2, a 3, and a 1. So we've got a 2 with 1 opening that would fit perfectly to do that 2. Then there's our 3 shaded, and then a 1 would go at the bottom, and that would complete that 4, meaning we can't put 1 here. Then, so we've dealt with that. Then I'm going to look at this one. So we've got that 1 up top, then a space, then 2, and again, we don't know where it's going to go yet. Then a space and a 1, and then the only other place we can put this one is there. So there's that other one. So this whole second from the bottom row now is full, which means that we can now fill in some of the vertical stuff. So this first column needs 4, so I have to add 1 at the top. This first column needs 5, add 1 at the top, and then both of those columns are full. Same deal over here, 4, and then 5, and that column's full. that kind of filled in the 8 for us across, so that's dealt with. And now the only way that the 6 can fit is if these two are both full. So that's dealt with. Now we've got one of the 2 satisfied, and so that one has to be empty. We've got the other 2, so now we've got all of those 2s satisfied. And there's our puzzle. So it kind of looks like, hey, it's Halloween themed. It's a jack-o'-lantern. Cute. So it kind of makes a picture at the end is the idea. So that's how a Hanjie works. Obviously these ones are much bigger. You guys can find like apps for this if you're like, oh my gosh, this boggles my mind and I just need easier ones. But again, like start with the big numbers. So like the 9, right? It has to take up at least that much space, and then maybe one, we don't know which outside it's at. So there's a few different strategies for that. Another massive Hanjie. This one's just a puzzle. You guys can logic it through together because I do want you guys working on this together, especially for dots and boxes. So I don't know if you guys have seen this game before, but generally everybody just grab a different color pen. It's easiest, I find, and everybody just takes turn drawing a line. So one person draws a line there, maybe the next person draws a line there, maybe the next person draws a line there, and what you're trying to do is set yourself up to make a box, and then you can put your initials in it, or just put like your first name, letter, or color it in your color if you're doing different colors. So you want to try and avoid being the third line. So if I'm kind of sketching like that, and then all of a sudden I make a line like this, then the next person whose player it is, or turn it is, can make that box. And if your line makes a box, then you get to do another line. And then if that one makes a box, then you get to do another line. And then if that one makes a box, you get to do another line. And then you do just a random line wherever you want. So the idea is either try and be stealthy and not let people see that you've set up a spot for a box. It often ends up just looking like big mazes without really any 3s. So maybe it kind of looks like that, right? And then at some point, somebody's gonna have to make a line that is gonna start enabling people to get boxes. And it kind of goes quickly once you do that. So I don't know if you guys have played this game before. If you haven't and you're really confused, you can ask me, but hopefully somebody's seen this before. So whoever's initial shows up most wins the game. So whoever dominates the board wins the game. And that is the logic puzzles for today. So as I say, you guys should work together on this. Like this is something that you will benefit from kind of working together. Please remember to maintain a little bit of distance and keep your masks on. Okay, let me know if you have questions.